Another video about simplifying imaginary numbers, only we're going to be dealing with powers of I, because a very interesting thing happens when you look at powers of I. There's a certain pattern that emerges that allows us to solve certain problems. In this case, these problems right here that I'm highlighting here. You'd be able to solve all these using this pattern that we're going to be going over right now. So first thing we're going to do is fill out this table right here, and it says x is 0, 1, 2, 3, 4, and so on. And then here we have I to the x. Okay. Now this I to the x just means it's going to be whatever the x value is over here, and for this first one it's 0. So this is just going to be I to the 0 power, essentially. So it's going to be I to the 0 power. Well, this is actually not too complicated. Anything to the 0 power is equal to 1. So if you fill that out, that's going to be equal to 1. Okay, the next one is I to the first. Well, that's just going to be I. Okay, anything to the first power is itself, so it's just going to be I for that one. Now 2, I already have it as -1 because we actually did go over this one already. Okay, I squared is equal to -1. If you did not see the video about complex numbers, you are going to want to watch that because it introduces the idea of what imaginary numbers are, and imaginary numbers are defined based on that I squared is equal to -1. Okay, so we know that one's -1. Okay, so far again, we're looking for a pattern. We have 1, I, and then -1. Next one is going to be I to the third, which is the same thing as saying I squared times I. Okay, because it's just, this is technically just I to the first. Okay, well, I squared is -1 times I to the first is just I. So your final answer for this one ends up being -I. Okay, so we have 1, we have I, we have -1, then we have -I, and then we're going to the fourth here. Well, I to the fourth is going to be equal to I squared times I squared, which is equal to -1 times -1, which is equal to 1. So if you notice now, this 1 that was right here repeats right here. Okay, now it only repeats once, so we're going to keep going just to make sure that it actually does follow that pattern. So let's keep going here. I to the fifth is just going to be, let's see, I to the fifth is going to be equal to, let's just break it down to the things we know. We know I to the third and we know I squared. Well, I to the third is right here, -I. So it's going to be -I times I squared. I squared is just -1. So -I times -1 is just going to be +I. Okay, so it goes 1 to I. Here, if you notice, it also goes from 1 to I. So it is repeating so far. All right, let's keep going. I to the sixth, let's just treat that as I to the third times I to the third. I to the third is equal to -I, so it's going to be -I quantity squared, which is going to be -I times -I. Well, that's -I quantity squared. I squared is -1, so this is just going to be -1 again. So if you notice, it goes 1I -1. If you notice here, it goes 1I -1. Okay, so far we definitely are following this pattern. Let's go with 7 here. 7 is going to be I to the seventh, which is equal to, let's just do I to the fourth times I to the third. Okay, the reason I did I to the fourth is because it's equal to 1. Okay, I to the fourth is definitely going to be your friend on this, so that's going to be 1 times I to the third, which is -I. So this ends up being -I again. And if you notice, it does follow the pattern: 1I, -1, -I. 1I, -1, -I. Okay, so it does follow that pattern. So based on this pattern, you should be able to know what I to the eighth is. So in this case, it is actually equal to 1. Okay, the pattern does repeat. So essentially, anything that's divisible by 4, it's going to be equal to 1. So I to something that's divisible by 4 is going to be equal to 1. And it follows that pattern throughout the entire thing. But it's good to have a I guess a home base when you're thinking about these problems. And I to the fourth, in my opinion, is easiest because it's just equal to 1. You don't have to worry about the negatives with the -1 or negative I. You don't have to worry about I. You can just worry about that whole number I. Just think every 4, it repeats to 1. That's the key to understanding all of this. And it's going to make more sense when we do example problems. This one's going to be I, because again, it repeats. This one's -1. This one's negative I. And then again, it repeats every 4. Anything that's divisible by 4. So this is going to be 1 again. Okay. So we are going to use the fact that I to the 4th is equal to 1. Okay. And just to kind of break this down a little bit further, you can think about it this way. I squared times I squared is equal to -1 times -1, because I squared is -1, which is equal to 1. So that's why I to the 4th is equal to 1. Okay, we kind of went over that already, but I just felt like reiterating it. Now, how can we use this to solve problems such as this one right here, where it's I to the 150th? Well, it would take forever to just keep following this pattern down. So what we're going to do is we're going to use that fact that I to the 4th is equal to 1 to solve this. Okay, so let's do this first one here. So I'm going to kind of rewrite it. I to the 150. Well, I to the 150, what I'm going to do is break this down into, I'm just going to do the place values, I guess, to start. So I to the 150, I'm going to break this down into I to the 100 times I to the 50. So this is just exponent properties. You learned about this in previous algebra classes. You can add the exponents up when you're multiplying, as long as the base is the same. Both base I, so you can add those up. Everything I've written down so far is completely equivalent. Now, what's cool about this is this I to the 100, we know that 100 is divisible by 4, okay? So if you did 100 divisible by 4, divided by 4 in your calculator, you get 25. Okay, so it is divisible by 4. So what I can do if I wanted, I can write I to the 4th and then raise this to the 25th power, because these powers multiply to get the 100. Okay, so let me do some highlighting here to make more sense of this. This part that I'm highlighting right here is equal to this part that I'm highlighting right here. Okay, you have to remember your exponent properties. A power of a power, you multiply those numbers to get that new power of 100. In this case, I broke it down. Okay, now the I to the 50, 50 is not divisible by 40, or I'm sorry, 50 is not divisible by 4, so I'm just going to rewrite the 50 there for now. I'm going to do one thing at a time here. Okay, well, this I to the 4th is equal to 1. So this part right in here is equal to 1. So technically you have 1 to the 25th times I to the 50. Now this 1 to the 25th is just equal to 1. 1 times itself 25 times is still equal to 1. So now you end up with just I to the 50. Okay, but we're not done yet. Because what you can do with this I to the 50 is you can break it down into powers that are actually equal, that are divisible by 4. Okay, in this case, I'm going to do 40. Okay, just because it's easy. I to the 40th and then I to the 10th here. Okay, well, I to the 40th is going to be equal to 1 because it's divisible by 4. It's going to be the same principle as what we did right here with the I to the 4th to the 25th power. Now, just for fun, I'm going to write that out. So it's going to be I to the 4th to the 10th power, because 10 times 4 is 40. So again, I'm going to highlight the equivalent statements. This is equivalent to this part right here. Okay. The 10 here, I'm actually going to break that down as well to an 8 and a 2. Okay, so this part is equal to this part right here. Again, I color-coded everything so you can kind of see what's equal to what. Okay, well, I to the 4th is 1, so this is just going to be 1 to the 10th, this part right here. So 1 to the 10th is just equal to 1. Okay, this I to the 8th, so it's just going to be 1 to the 10th. This I to the 8th is also going to be equal to 1 because it's I to the 4th squared. I guess I can write that down. So that's equal to 1. And then I squared is equal to -1. So now if you notice, this last step that we have here, it's just going to be, this is equal to 1. So it's going to be 1 times -1. So your final answer for this one is equal to -1. Okay. Now it seemed like a lot of work to do that, and I did write down more work than I really had to, because as long as you see something is divisible by 4, you can just kind of get rid of it. Okay, I to the 100th, I could have just right away, this part right here, I could have just said that was equal to 1. But instead I broke it down to the I to the 4th, just so you can kind of see where it comes from. But again, you don't actually need to do that. As long as you know that it's divisible by 4, you can just write a 1 in there right away. Okay. Now, what's really cool about these problems too is that your calculator actually can do mathematics on imaginary numbers. So what I'm going to do is show you how to do this entire problem in your calculator, and you should end up with the same answer that I got on the bottom of -1. So here we go. So what I'm going to do is do I to the 150th. So to do that, what you need to do is hit second decimal point. So second I to the 150th power. Okay, and then you hit enter. And if you notice, you get this weird answer on this. So what I'm gonna do is screenshot this and throw it in my, my whiteboard just to kind of analyze what this means. So calculators are not actually calculating anything the way we did it. They're actually just counting, okay? And this counting sometimes can lead to errors, okay? In this case, the error is on the calculator, not on us. But essentially what you're looking at here for the answer is it says -1 minus 5 times 10 to the -12. So if I was going to rewrite this, it'd be like this, times 10 to the -12 times I. Okay, that's what this is saying. That's what this capital E represents, times 10 to the -12. Okay, and then times I at the end of it. Well, the thing you need to understand here is this part right here is basically 0. In real life, it is 0, but again, the calculator is counting and it miscounted on parts of them. Okay, so really what this is supposed to do is represent 0. So then you have to do -1 minus 0 times I. In this case, it would just be -1 because 0 times I is 0. And if you notice, that does match our answer over here. Main point of this is your calculator does lead to errors, but it can still help you find the correct answer. You just have to know, using your human brain, that this part is actually supposed to represent 0. Okay, once you know that, then you can use your calculator to check that. If you do write this as your answer on a test, it will be marked wrong because you didn't show any work, A, and B, you didn't understand what you were doing. Okay, you didn't understand that the calculator basically gives you an error because it's just a counting error. But you have to know that you have to ignore it. So the next one is I to the 34th power. And what we're going to do right away is, again, just break that down into anything that's a power of 4. And the biggest one that you can think of is the best, but if not, then just you can go by 4s each time. That also works. But what I'm going to do is do the biggest power of 4 that I know of in this, and that's 32. So 32, if you take that away from 34, you still have 2 left over, so I'm going to put the 2 here. Okay. Now, I to the 32 is equal to 1 because it's divisible by 4. The I squared is equal to -1, so you end up with 1 times -1, which is equal to -1. Okay. Now I'm going to try that. I'm going to check that on my calculator really quick just to make sure I did that right. And you get -1 minus basically 0 times I. So again, it should just be -1 minus 0I, which is -1. Cool, let's do the next one. So the next one is I to the 1294th power. Okay, now this might seem intimidating, but I'm gonna kind of just show you why this actually is not that bad. Okay, well, anything in the hundreds place is automatically divisible by 4. Okay, so that 200 is divisible by 4. Well, since everything in the 100s place is divisible by 4, that means everything in the thousands place has to be divisible by 4, everything in the 100,000s place. So essentially what you could do if you wanted is you can get rid of anything in the hundredths place and the thousandths place right off the bat. So this 1 and this 2 you can get rid of, and it's just equal to I to the 94. Now we can break down the 94. Okay, the biggest number that I can think of that's pretty easy to work with is going to be 80. So I'm going to do I to the 80 and I to the 14th. Now, if you wanted to, you could do I to the 84. I'm just trying to keep it simple when I do these, just because it's less error prone. But if you did I to the 84th, that works too. There's multiple ways of doing this. I to the 80th, because that power is divisible by 4, that's equal to 1. Now, this I to the 14th, I'm going to break that down into I to the 12th, because I know that's divisible by 4, times I squared. Okay. So then this means it's equal to 1 times I squared, which is just equal to -1. So we keep getting -1 as the answer for these. But that's okay. That is the answer for that one. Okay. They don't all have the answer of -1. I just didn't pick the best problems, apparently. All right, this next one is I to the 761st. So I to the 761st. Okay. Now, if you remember for this one, anything in the hundreds power you can just kind of ignore. So right away, I'm just going to go straight to the 61. Okay. Well, I know that 60 is divisible by 4 because of a clock. So I'm going to make this 60 and this I to the first. And then from here, I to the 60 is equal to 1. So it's 1 times I. I is your final answer. Okay. Again, you can use your calculator to test that out. So if I just did I to the 761st power, and you end up with 1.89 times 10 to the negative 11th, so that's basically 0 plus I. 0 plus I is I, which is what we got. Okay, and then the last one is I to the 97th. Okay, so if we broke this down, I'm gonna right away just take out 80, and then I to the 17th. Okay, I to the 80 is 1. Then I'm gonna multiply this by I to the 16th times I. Okay, 16 is divisible by 4, so it's 1 times I, and you end up with I again for the answer. So that's basically a video on simplifying imaginary numbers when you have powers of I. If you have any questions about any of this video, let me know.